Alright, before we start, why don't you go ahead and find the cycle structure for this permutation. It's good practice, even though we're going to look at conjugates here. So I'll pause and then come back. Pausing. Okay, so there's a 2-cycle, a 2-cycle, and a 3-cycle. So basically, we have these corners being swapped, those corners being swapped, and then something like this, upright to up back to front right. So that's the situation. Now this is a commutator, right? This is, you do something else, you do the you undo what you're doing, and then you undo the first thing. So this is a commutator, which, as I said, they can be a useful place to start when solving a puzzle. What we're going to do is do some repetition. That's one way to make use of something we find, repetition. Notice that if we repeat this 3 times, this permutation, this 3-cycle of edges is going to get washed out. What do I mean by that? Well, let's take a look. If I do this 3 times, these edges they're going to be back to where they started. So if I do this is once, so I'll do RURiUi, RURiUi. Notice that the edges are all back. We just have a pair of 2 cycles on the corners, right? So we just have something like this. Alright, so we have up, front, down, front, and then we have up, back, left, going to up, back, right. Now, it is a bit more complicated than that, in that if I do this an even number of times, even though the corners are back, they're not oriented correctly. That is, if I did this again, notice that the red, green, blue, red, green, yellow piece is in the right location, red, green, yellow, but it's not oriented correctly. We'll make use of that in just a second. Now, one of the things, and we'll talk about this when we talk about how speed cubing is accomplished, is this is the same sort of commutator we've looked at a bunch of different times. We've looked at FR, FI, RI, we've looked at FIR, RI, we've looked at FU, FI, UI. These are all essentially the same kind of commutator. They have the same cycle structure. This one is really nice though, if speed is of interest, and it's called the trigger, or it's associated with the trigger. The idea is, as I do the R, my index finger is ready to do the U, and then as I put the RI back, my other index finger does the UI. And so you can run through this very quickly. And so you'll find, we'll do this in class, that whenever we can utilize this particular set of twists, it's really valuable, because you can proceed through them very quickly. And in fact, the point of choosing this is we're going to develop a permutation that's useful in what's called 2-look OLL. Alright, so we have this repetition here, which got rid of all the edges. So this is there's less going on, which is good. But it's going on in too many places. The way we solve the cube is from top to bottom, not usually from a corner out, but sometimes. So here's what we can do. We can make a conjugate of this process. If I want to restrict what this permutation does to the cube, suppose I want to do something like this. Right. This is going to be, I shouldn't say easy, but let's think about how this would work. We have to move these corners into this position. So if I want these two corners to get swapped, I have to put them in the locations that are affected by this permutation. So I'm doing an F before I'm going to do this permutation, and then I'll do an Fi afterwards. This is my setup. This is my inverse setup. So let's see how that works. Right? So I'm going to do F, and then RURiUi, 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 Fi. So let's see what happened. The piece that used to be here, which was yellow, blue, and red, is now over here. The piece that used to be here, which was yellow, green, and red, that's over here. So these two have swapped. So of these two, we've accomplished what we wanted, which was up, front, right, up, front, left, and back, and then up, back, left, to up, back, right. Now, is this useful at all? Yeah, actually. So one of the methods of solving a cube faster is to have more permutations for this last layer. So the slower approach to solving the cube is, after you have this cross, is to go through an algorithm up to 3 times. In fact, it's that the R, U, Ri, U, R, U squared, Ri, 1, 2, or 3 times. Well, the idea of what's called 2-look OLL is to get this to be all yellow in just one permutation all the time, and preferably fast permutations. So this is pretty fast actually, but what this does is it swaps corners, right? But it also twists them. So these are called, I forget if they're called headlights or taillights or whatever. There's various names for these things. Well, let's just try. What happens if I do this? Again, it moves these. That's what we've been focusing on. But it also apparently twists them. So if I do F, and then I do this RURi, RURi, right? The pieces go back to their home locations and they twist. So let's look at that again. So we have this situation where the pieces are being exchanged and they're being twisted. They're being oriented differently. Now in our class, we're not worrying too much with the orientation. It's a side note, but I want to point it out that this process, which might seem clunky, of finding a commutator, doing some repetition, restricting its effect by a conjugate, can be of use. It turns out that we're not interested in swapping the pieces with this commutator, this conjugate of a repeated commutator, but rather the fact that as they move, they twist in a predictable way, so that these 4 pieces will be yellow on top. All right. So let me set up something to make that more apparent. So it doesn't matter necessarily where the pieces go. So if I did something something like this, and let's see, what do I want? I want something like that, and so yeah, if I were solving the cube and I get to this stage, one way of dealing with this in the Rubix.com method is to go ahead and work this algorithm out, right? I think it goes something like, you do one iteration like this, and then you have this pattern, and you do another iteration, and then you get to the solid yellow. But you don't necessarily have to do that. Alright, hold on. I'll set up. Oops. So if instead we came to the cross and we had our yellows here and here, then instead of doing 2 iterations of this, we could just do this one permutation and have it entirely yellow on top. So it's in this way that useful permutations are created. They're hammered out of fairly basic ideas, simple commutators or simple moves that with small tweaks end up having useful consequences.